Hello Year 11. This video relates to exercise 14I and exercise 14J. It makes sense to actually cover these in one video, although I may actually pause the video at certain points. But two exercises covered here. They involve sketching trig functions. Okay. 14I, sketch graphs of y equals a sine n bracket t plus or minus epsilon or epsilon, and y equals a cos that should be. So I've just spotted an error here. I was half asleep, so we can change that to cos n bracket t plus or minus epsilon. Okay, I don't know if the correct pronunciation is epsilon, epsilon, or something different. Either way, I think you get it. It's a Greek symbol there, Greek letter. Okay, so this exercise uses the axes y versus t, not y versus x. Okay, but it's the same concepts. Okay, whether you use t or x. And we're talking about horizontal translations. The graph y equals a sine n t minus epsilon is translated epsilon units to the right. So when there's a negative sign in here, we're talking about a translation to the right in the positive direction. And that's not inconsistent with some of the work with functions you've done earlier in the year, where you've got brackets and you've got a negative sign in the bracket, but that actually refers to a translation to the right. The graph of y equals a sine n t plus epsilon is translated epsilon units to the left. So negative here means positive translation, positive here means negative translation. So this one is to the right, this one is to the left. This value, epsilon, is called the phase, and the translation is called a phase shift. So we're talking about a phase shift when you have one of these coefficients here. What I've put here where I've written sine can also be applied to cosine graphs. I just, obviously I didn't feel the need to write that twice. So you might want to pause here and copy this in your notes, or take a screenshot, whatever you like. But you're watching a video, so you could just as easily pause this and write it down, or take it from your book. What I want to do next is actually look at a particular example. It's asking us here to draw the graph of the following function. Y equals 3 sine 2 bracket t minus pi on 4, with the domain restricted to pi on 4 to 5 pi on 4. Sorry, I'll move that down again. So yes, draw the graph of the following function. 3 sine 2 bracket t minus pi on 4 between pi on 4 and 5 pi on 4. You can see already that I've come in and I've underlined these coefficients, or these values here. That's not a coefficient, but it is a value. So what we have is we have a graph where we have an amplitude of 3. Okay, we have a period of 2 pi on 2, which equals pi, and we have a horizontal translation of pi on 4 units to the right. So we then need to sketch that. So if I'm going to do a quick sketch of it, what I need to do is I need to draw in an axis. So let's do that. Okay, let's put that there, and let's do this. So we've got 2, 4, 6, 8. Let's go 2, 4, 6, 8 there. 2, 4, 6, 8. Now, it's probably best if we just come up here and I set that and I mark that. Now I can come in straight away and I can say, well, this value here is 3, this value here is -3. And then I can actually start here and I can do this, walk there, I can go up, I can go down, I can go about here, and I can do that. So, I'm doing this by hand, so it's not perfect, but it's not bad. If I do say so myself, come through like that. It's got a bit of a wobble there. I think you get the idea though. Okay, so there's my graph. What are these values though? Okay, this is going to be, everything has been shifted pi on 4 units to the right. So this is going to be pi on 4. And the period is pi, so this is going to be 5 pi on 4. Because the period is 1/4 pi plus 4/4 of pi, so that's 5 pi on 4, and halfway between 1 and 5 is 3. So this point here is 3 pi on 4, and this amplitude up here is 3. This amplitude down here is 3. So this is actually the sketch between pi on 4 and 5 pi on 4. And to keep it to scale, this value here is 6 pi on 4. Okay, that's that's the worked example. Hopefully that helps. That's one of your worked examples anyway. Okay, now just some language that they use. I've said here that the amplitude is 3. So what that means is that there is a dilation factor of 3 from the t-axis. Okay, and there is a dilation factor of half from the y-axis. Basically, it means that the graph has been shrunk. And there is also a translation of pi on 4 units in the positive direction. I put that there because in the exercise, in question 5, it says find the equation for the following transformations. So you need that language to do question 5 in the exercise. Okay, so you've got that there on screen as well. So that covers 14i. That covers 14i. I might actually pause it there because I had something that I was going to put in front and I don't seem to have it. Here it is. So 14i is there. No, that was the one I had previously. And I put that on the floor. I was looking for 14j. It's this one here. Alright. So exercise 14, I got there in the end, didn't I? Exercise 14J is about sketching graphs of y equals a sine n bracket t plus or minus epsilon plus or minus b. So there's that extra element, that extra term in the equation there. And you probably realise already that this is a translation parallel to the x-axis. Okay, these questions are the same as exercise 14I, with the added effect that plus or minus b translates the graph plus or minus b units parallel to the x-axis. It moves the graph up or down by b units. So what you're asked to do here is you're asked to sketch graphs. Okay, now you've got a question again in the example where it asks you to sketch each of the following graphs. I'll look at this one again. We've got this example. It is y equals 3 sine 2 bracket t minus pi on 4 plus 2 between pi on 4 and 5 pi on 4. Now, that is actually very, very similar to the previous question. Okay, so what we can do is I'll put that back in front of you there. Now, the graph's going to have that shape. Okay, this is the value 0, but for the new example, this actually becomes the value 2. Okay, and when you're actually going to sketch it, it's quite useful to do that. Okay, that's 2. Now this would be, I made that 3 units. So 2 minus 3, that's actually -1. That's -1. And this is 2 plus 3. This is 5. If you look at the graph that they have in on page 510 of your text, they have a graph that looks like that, except it doesn't have this. This is not the axis anymore. So what I'm going to do is I'm going to actually rub out these. Okay, if I rub out these, and we say, right, well, hang on, where is our axis now? Where is our axis now? This is the axis of symmetry, or it's the translated axis, if you like, of this graph. But where is 0 in effect? Okay, now that's so it's going to be about here. It's about there. So let's draw that in there. No, that's not right. That's 2, 1. So it's, I did that. I looked at it and I thought, no, that's not right. It's actually going to be about here. So what's that distance there? That's about, yeah. Zero is going to be about here. But sorry, I'm taking my time on this. So that's 0 there, that's -1, that's 2, That's 5. So if we really want to make this good, what we do is we go over this in pen. If it's going to work. Ink doesn't go on pen real well sometimes. Alright. We go over this in pen. Then we rub out this one. And then we've got this here. So what I've done here is I've done literally the same graph, okay, literally the same graph, but I've just shifted everything up. I've shifted everything up by 2 units because the plus 2 there, okay. So that's the effect of that translation upwards, but I've still kept it between the ranges of, this is still pi on 4, and this value here is still 5 pi on 4. Okay, but that is the graph. That is the graph. And that's the effect of translating up and down. Now, sometimes what we need to do sometimes is we need to find these values of these x-intercepts too. So how do we find the x-intercept? What we do is we say we solve this for 0, or we solve this function. So let's see if I can do it with this one. This is going to be, this one's not done for me, so I'm going to see if I can do it. To find the x-intercepts, they're called t-intercepts actually. And we're looking for time. Solve for 0. I'll solve for what? Solve for y. I'm going to pause there, make sure I can do this, and then run through it with you. Okay, that one, in terms of finding the x-intercepts of that previous one I was looking at, that one's actually a little bit beyond what we're trying to get you to do. So I'm going to go to this example. Okay, this comes from example 23. It's asking you to sketch the graph of y equals 2 sine 2 bracket x minus pi on 3 or minus root 3. Okay, so what we'll do is we'll do the same thing that we did with the last one, where we've got, I like to come in and I like to underline these things here. Okay, so our amplitude is 2. Okay, and our period is 2 pi over 2, which equals pi. Then we have a translation, which is pi on 3 to the right, and we have a translation which is root 3 units down. If we go about drawing that, what we need to do is we need to actually draw ourselves the graph. So So we're dealing with a sine curve. And what do we got? We've got a period of pi, and we have a domain of, that wasn't here, the domain we want is between 0 and 2 pi. Now if our period here is pi, then we want approximately 2 periods of, well, we want 2 periods of the graph showing. 2 periods of the graph showing. So what I'm going to do is I'm going to draw a sine graph with 2 periods. I'm going to start, and if you need to sketch these by hand, this is what you need to do. We're going to start by drawing, just drawing some axes in there. And what I'm going to do is I'm going to draw a sine graph that has 2 periods to it. Okay, and then I'm going to muck around with it a bit. So there's one. And there's 2. Now I might need to crop this a bit, or make some adjustments to this. This is a regular sine graph. It's got 2 periods to it. Okay. Now what we have is the amplitude is 2. The period is 2 pi over 2, which is pi. We have a translation √3 units down. Okay, so this middle of the graph, this point here, or this line, is actually a value of -√3. So this line is -√3. This value here is -2√3. And this value here is -√3 plus 2. I'm just going to write that in as it is there. It's -√3 plus 2. Okay, you can work out an approximate value for that. So that is pi. That is 2 pi. But what do we need to know? We need to know what the x-intercepts are. So 0 a 0 line is going to be about here somewhere. Because -√3 plus 2, I'm just going to work out what that is. So I'm going to say, oops, I'm going to go to calculator. Sorry, a bit slow here. -√3 plus 2, and just get an approximate value on that. That's 0.26. This is 0.26, which means that 0 is there, so that's probably about right. This is approximately 0.26. Or actually 0.27 if you go 1 decimal place. So that's roughly what the sketch looks like, and it is a sketch of y equals 2 sine 2 x minus pi on 3 minus root 3. Now,